Hi, my good friends. My name is Kepsi and welcome to my online tutorials. Our discussion on numerical and computational method will be on finite difference, and our attention will be finding the polynomial function connecting two sets of related values. Do you have an idea on mapping and how to find the rule for mapping? For instance, if we have a mapping x map to y, where 1 corresponds to 2, 2 map to 4, 3 map to 6, 4 map to 8. You can see twice of 1 is 2, twice of 2 is 4, twice of 3 is 6, and twice of 4 is 8. So we can say the rule for this mapping is y equal to 2x. What of if we have this set of values, where 1 map to 9, 2 map to 15, 3 map to 23, 4 map to 33, 5 map to 45, and 6 map to 59. Can we easily find the rule? No. But however, anytime we are faced with such situations, a finite difference comes in to help us find the polynomial function that connect those two sets of values. So our idea is to just construct a difference table. Please, did you watch my video on difference table? Check it out on YouTube. So having constructed a difference table, it will help you determine the form of polynomial function that connect x to y. Whether it is a second degree polynomial function, it is a third degree polynomial function, in that order. So now we'll take some sample questions and see how we can find the polynomial function that connect two sets of values. So look at our first example. It says construct a difference table for the set of values below and use it to determine the polynomial function connecting the value of x and y. And the values of x are 1, 2, 3, 4, 5, 6. Their corresponding values for y is 9, 15, 23, 33, 45, and 59. So please, if you made this question like this, the first thing, whether you are asked to find the polynomial function without asking you to construct a difference table, there is the need to construct a difference table. Please, this is how we construct a difference table. So we draw a set of values for x and y, leaving space between them. Please check out my videos on how to construct difference table on YouTube. So this is how we do 50 minus 9 is 6, 23 minus 15 is 8, 33 minus 23 is 10, 45 minus 33 is 12, and 59 minus 45 is 40. Since it's not constant, you go further to find the second difference. So the second difference, that del square y is 8 minus 6 is 2, 10 minus 8 is 2, 12 minus 10 is 2, and 40 minus 12 is 2. Since it's now constant, we know that the polynomial function connecting x and y is of degree 2. So the polynomial function will be in the form y is equal to ax squared plus bx plus c. I hope you get that. So immediately the difference table helps you to determine the form of the polynomial function. There is the need to construct another polynomial function. So having determined the polynomial function connecting x and y is of the form y is equal to ax squared plus bx plus c, there is a need to substitute the x values into our polynomial function and write it as the values as y in the y columns. So when we substitute 1 here, 1 square is 1 times a will be a, b times 1, that will be b, then plus the c constant. When we substitute 2 square is 4 times a, that will be 4a, then times b, that will be 2b, then plus the constant c. We substitute the 3 to get 9a squared, 9a plus 3b, then plus c. 3 square is 9 times a will give you 9a. 4 square is 16 times a, that will be 16a plus 4b, then plus c. Then 5 square is 25, so that will be 25a plus 5b, then plus the constant c. Now substitute 6. 6 square is 36a plus the 6b, then plus c. So we will find the difference between the y, that's the first difference of the y, just as we find for this table. So we are going to do that. So we said del y. How do we do that? So we subtract these values from this. So now we find the difference between the values of the y. So 4a minus a, that will give us 3a, 2b minus b, that will give us b. Then c minus c is 0, so we'll write. Then 9a minus 4a, that will give us 5a. Then 3b minus b, minus 2b, that will be b. Then c minus c will be 0. We find the difference between this and this again. 16a minus 9a, that will give us 7a. Then 4b minus b, that will be plus b. C minus c is 0. We find the difference between this and this. 25 minus 16, that will give us 9a. Then 5b minus 4b, that will be positive b, that's plus b. Then c minus c again will give us 0. Then we will do for this, the difference between this and this. We subtract the whole of this from the whole of that. 36a minus 25a, that will be 11a. Then 6b minus 5b, that will be b. Then c minus c again is 0. We'll go further. Since our polynomial is of second degree, we'll find the second difference. That's del square y. That's the difference between this and this. On subtract 3a from 5a, we'll get 2a. b minus b is 0. On subtract 5a from 7a, we'll get 2a. b minus b again is 0. On subtract 7a from 9a, we'll get 2a. b minus b again is 0. On subtract 9a from 11a is 2a. b minus b is 0. That backtraces the point that it's a second degree polynomial because all these are constants. So what happened? It simply means that all the set of values here, 2, 2, 2, 2, are equal to the set of values here, 2a, 2a, 2a. And the set of values here, 6, 8, 10, 12, 14, are equal to the set of values here. So 6 is equal to 3a plus b, 8 is equal to 5a plus b, 10 is equal to 7a plus b, 12 is equal to 9a plus b in that order. Then 14 is equal to 11a plus b. Also, 9 is equal to a plus b plus c. 15 is equal to 4a plus 2b plus c in that order. So how do we find the values of what? A, b, and c. So we can say 2a is equal to 2, right? So if 2a is equal to 2, we divide both sides by 2, our a is 1. Also, you can pick any of these and equate it to their corresponding values to find the b. So I'll pick the first. 6 is equal to 3a plus b. So I can say 6 is equal to 3a plus b. What's my a? My a is 1. I'll substitute. So 3 times 1 plus b. 6 is equal to 3 plus b. 6 minus 3 is equal to b. And our b is 3. So a is 3, a is 1, b is 3. Now how do we find c? We'll pick any of these again. You realize that 9 is equal to a plus b plus c. So we equate that to find the value of c. So, as I said, you can say 9 is equal to a plus b plus c. So, we can say a plus b plus c is equal to 9. Our a is 1, so we substitute. Our b is 3, we substitute. Then plus c is equal to 9. 1 plus 3 is 4, plus c equal to 9. Our c equal to 9 minus 4, and c is 5. So, we realize our a is 1, we substitute. Our b is 3, we substitute. And c is 5, we substitute. So, we can say that the polynomial function connecting x and y is y equal to x squared plus 3x, then plus 5. If you want to find out whether you are correct, you can substitute all the values of x here into this polynomial function. You will get their corresponding values for the y. That's very interesting. That's one power about the difference table. We'll solve one more example on this so that you'll be abreast with the concept. So let's look at our second example. They say determine the equation of the function that is represented by the following table of values. And the values of x are negative 1, 1, 3, 5, and 7. The corresponding value of the y is 1, 9, 1, negative 23, negative 63. Or in other words, negative 1 mapped to 1, 1 mapped to 9, 3 mapped to 1, 5 mapped to negative 23, and 7 mapped to negative 63. So, in order to determine the function, the first thing you need to do is to construct a difference table. So we have the difference table like this. What do? We find the first difference. That's 9 minus 1 is 8. 1 minus 9 is negative 8. Negative 23 minus 1 will give you negative 24. Then negative 63 minus negative 23. Okay. Negative 63 minus negative 23 will give you negative 40. Now, since the first difference does not give us a constant or the same, we go further to find the second difference. Negative 8 minus 8 will give us negative 16. Negative 24 minus negative 8 will give us negative 16. And negative 14 minus negative 24 will give us negative 16. So, now you see that the second difference are the same, or is of the same value. Then we know that our polynomial function is a second degree polynomial function of the form y is equal to ax squared plus bx plus c. How do we determine that polynomial function? There is the need to construct another difference table. So having identified our polynomial function of the form ax squared plus bx plus c, we construct another difference table by substituting the values of the x into the polynomial function to get the y. So we substitute negative 1 here in place of x. Negative 1 squared is 1 times a will be a. Then negative 1 times b will be negative b, then plus c. We substitute 1 squared is 1 times a will be a. 1 times b will be b, then plus our constant c. We substitute 3 squared is 9, times a will be 9a, then 3 times b will be 3b, then plus our constant c. We substitute 5 squared is 25, so 25a, 5 times b will be 5b, then plus our constant c. We substitute 7 squared is 49, times the a plus the 7b plus our constant c. Now we find the first difference between this set of values. We subtract this from this from that, this from this, and this from this. So a minus a here will be 0. B minus negative b, that will be 2b. So we'll write 2b here. I hope you get that. So b minus negative b, that will be b plus b, and that's 2b. Now we find the difference between this and this as well. 9a minus a, that will be 8a. Let me write this with red. Then 3b minus b, that will be 2b. C minus c will give us 0. Then this and this. 9a minus 25a, that will give us 16a. Then 5b minus 3b, that will be 2b. C minus c will give us 0. Then this minus these two. So 49a minus 25a, that will give us 24a. Then 7b minus 5b, that will be 2b. C minus c will give us 0 as well. We go further. Since we know that our polynomial is a second degree polynomial, we find the second difference as well. So this minus this. So 8a minus 2b. So the 2b will subtract this 2b. We'll be left with 8a. Then 8a minus 16a will give us 8a. Then 2b minus 2b will be 0. 24a minus 16a will give us 8a. Then 2b minus 2b will give us 0. Identify, having formed the difference table for our having formed our second difference table, we are just going to equate. This means that negative 16 is equal to 8a, negative 16 is equal to 8a, negative 16 is equal to 8a. This 8 here is equal to 2b. Then this negative 8 is equal to 8a plus 2b. This negative 24 is equal to 16a plus 2b. And negative 40 is equal to 24a plus 2b. You can pick any of them. You equate, you find their corresponding values. 1 is equal to a minus b plus c. 9 is equal to a plus b plus c. 1 is equal to 9a plus 3b plus c, in that order. So let's find the first one. Negative 16 is equal to 8a. We can say 8a is equal to negative 16. We divide both sides by 8. A is equal to negative 2. I hope you get that. Now 2b is equal to 8. So we can say 2b is equal to 8. We divide both sides by 2. Our b is 4. So now we want to find the value of c. How do we know the value of a and b? So we know that a minus b plus c is equal to 1. Or a plus b plus c is equal to 9. Any one you pick, you get the same value. So I want to pick a plus b plus c equal to 9. So a plus b plus c is equal to 9. Our a is negative 2, b is 4, plus c is equal to 9. Negative 2 plus 4 is 2, plus c equal to 9. C is equal to 9 minus 2, and c is 7. So we know c to be 7, a to be negative 2, b to be 4. We just substitute here to get that polynomial function that connects x and y. So that polynomial function will be equal to, in place of a, negative 2, so negative 2x squared. B is 4, so plus 4x, and c is 7, so plus 7. If you substitute these values of x into this polynomial function, you will get all these values for y. Try it and see. So this is all about finding a polynomial function that connects two sets of values. Now let's solve another one where we have a cubic polynomial function. So let's look at our third example. Say determine the equation of the function that is represented by the following table of values. And the values of the x are 1, 3, 5, 7, 9, 11. And their respective corresponding values of y are negative 4, negative 92, negative 396, negative 1060, negative 2228, and negative 4044. So how do we do that? So first, you need to construct a difference table of this nature. So the x values are this. You leave spaces to write the differences and the corresponding y value. Please do well to check out my videos on how to construct difference table. It will help. So negative 92 minus negative 4 will be negative 88. Negative 396 minus negative 92 will give us negative 304. Negative 1060 minus negative 396 will be negative 664. Then negative 2228 minus negative 1060 will be negative 1168. Then negative 1816, negative 4044 minus negative 2228 will give us negative 1860. So since the first difference does not produce a constant, you go further to find the second difference. So negative 304 minus negative 88 will be negative 216. Negative 664 minus negative 304 will be negative 360. Negative 1168 minus negative 664 will give us negative 504. Then negative 1116 minus negative 1168 will give us negative 648. The second difference does not produce a constant. We go to the third difference. So negative 360 minus negative 260 will give us negative 144. Negative 504 minus negative 360 will give us negative 144. And negative 648 minus negative 504 will give us negative 144. So you see that the third difference produces the same values. Then we can say that the polynomial that connects x and y is of the form y equal to ax cubed plus bx squared plus cx plus d. Now we need to find the values of a, b, c, and d by constructing another difference table and substituting the values of the x into this to find the y. So having identified that our polynomial function is of the form ax cubed plus bx squared plus cx plus d, we substitute the values of y into them to get the y. So 1 cube is 1 times a, that will be a. 1 square is 1 times b, that will be b. Then 1 times c is c, that will be c. Then plus our constant d. Now we come here. 3 cube is 27 times the a. 3 square is 9, so 9 times the b. Then plus 3c, then plus our constant d. 5 cube is 125, so that will be 125a. then 5 squared is 25, 25b plus 5c, then plus d. 7 cubed will give us 343. So 343a square, 7 square is 49, so 49b plus 7c, and plus d. Now we come here. 9 cubed will give us 729, so 729a. 9 square is 81b plus the 9c, then plus d. Then the last one, 11 cubed will be 1,331, then times the a. 11 square is 121b, then plus 11c, then plus the constant d. Now we find the difference between this set of values to get the first difference of y. So we substitute, so now we find our first difference, the first difference of y. We subtract all this from this. So 27a minus a, that will give us 26a. Then 9b minus b, that will be 8b. Then 3c minus c, that will be 2c. Then a d minus d will be 0. Find the difference between this and this. 125a minus 27a will give us 98a. Then 25b minus 9b, that will be 16b. Then 5c minus 3c, that will be 2c. Then d minus d will be 0. Now we come here. 343 minus 125 will give us 218a. Then 49b minus 25b will give us 24b. Then 7c minus 5c, that will be 2c. D minus d will be 0 again. Then 729a minus 343a will be 386a. Then 81b minus 49b, that will be 32b. Then 9c minus 7c, that will be 2c. And d minus d again is 0. Now, we subtract this from this. 1331a minus 729a will be 602a. Then 121b minus 81b, that will be 40b. Then 11c minus 9c is still 2c. D minus d will be 0. Now we'll go further to find the second difference. So find our second difference, which is del square y. That means we subtract this value from this from this, this from this, and this from that. So I'm going to subtract 26a from 98a. We'll get 72a. Then 16b minus 8b will be 8b. 2c minus 2c will give us 0. Then we'll go again. 280 minus 98 will be 120a. Then 24b minus 16b will be 8b again. This from this as well. On subtract 218 from 386, we'll get 168a. Then this from this, that's 32b minus 24b will give us b. 2c minus 2c again will be 0. Now this from this, 602 minus 386 will give us 216a. Then this from this will be 8b. 2c minus 2c again will be 0. I hope you get that. So since our polynomial involves third degree, we'll go further to find the third difference. So we'll find the third difference. Now 120a minus 72a will be 48a. 8b minus 8b will be 0. So once subtract all the b's will go, it will be left with a. So this from this again will be 48a. Then this from this will be 48a. Remember the 8, we have 8 b's throughout. When we subtract, so this is also 48. Now having gotten those values for x and y, it implies that all the values here is equal to all the values here. All the ones here are corresponding to this. all these here are corresponding to this. Then all these one here are also corresponding to this. So we can find the values of A, B, C, and D. Then we substitute. So now let's equate to get our values. So we can say 48A, that's this, is equal to negative 144. We divide both sides by 48, here by 48. A will be equal to negative 3. Now we find B. So we know that 72A plus 8B will be equal to negative 216. So 72A plus 8B will be equal to negative 216. We substitute. So we have 72, A is negative 3. We substitute there. Plus is equal to negative 216. So 72 times negative 3, that will be negative 216 plus 8b will be equal to negative 216. So 8b will be equal to negative 216 plus 216. 8b, negative 216 plus 216 is 0. We divide both sides by 8, b is 0. So a is negative 3, b is 0. So we can also say that 26a plus 8b plus 2c is equal to negative 88. So now we substitute. We know a to be negative 3. So 26 times negative 3, b is 0, then plus our 2c will be equal to negative 88. 26 times negative 3 will be negative 78. 8 times 0 is 0, so plus our 2c is equal to negative 88. 2c is equal to negative 88 plus 78. So our 2c will be negative 10. When we divide both sides by 2, c will be equal to negative 5. I hope you get that. So we can say our c is negative 5. So we can also say that A plus B plus C plus D is equal to negative 4. I hope you get that. So, A plus B plus C plus D is equal to negative 4. What's A? A is negative 3, B is 0, C is negative 5, and plus D will give us negative 8. Negative 3 plus 0 is negative 3 minus 5 or plus negative 5 will be negative, okay, this is negative 4, will be negative 8 plus d equal to negative 4. So our d will be equal to negative 4 plus 8, d is equal to 4. So we know our d now to be equal to 4. So having know a to be negative 3, b is 0, c is negative 5, and d is 4, we substitute into our polynomial function to get that polynomial function that connects x and y. So we can now say that our polynomial function will be equal to y is equal to a is negative 3, so negative 3x squared, b is 0, b times that will be 0, so it will, the second degree will not be part again, and c is negative 5, so minus 5x, d is 4, so plus 4. Then we can say this is our polynomial function that connect x and y. We'll solve one more example on cubic polynomial function so that you get a full glance. So please, we'll solve our last example on this. Did you subscribe to my YouTube channel? Please do. It is the only way you can help me promote my YouTube channel so that YouTube can suggest my videos to others and I can record more mathematical content for you. Like, comment, and share my videos. So the last example is we should find the rule of the mapping below. So this is a mapping. Maybe someone knows mapping and you're asked to find the rule for this mapping. How do you do that? Okay. So you need to construct difference table for this. You write all the values of the x here, you can see, and the values and their corresponding value of the y there. Then we find the first difference. The first difference of the y, 30 minus 7 is 6, 43 minus 30 is 30, 145 minus 43 is 102, 167 minus 145 is 222. Then 759 minus 367 is 390. Since the first difference does not produce constant, we go to the second difference. 30 minus 6 is 24. 102 minus 30 is 72. 222 minus 102 is 120. And 390 minus 222 is 168. The second difference does not produce a constant, so we go to the third difference. 72 minus 24 is 48. 120 minus 72 is 48. 168 minus 120 is 48. The third difference produces constants which are the same. Then we can say that our polynomial function is a cubic polynomial function, and it's of the form y is equal to ax cubed plus bx squared plus cx plus d. So having identified that our polynomial function is a cubic polynomial function, we substitute these values into the polynomial function and write them here. So we substitute 0. 0 cubed, 0 times a is 0. 0 squared is 0 times b is 0. C times 0 is 0. So what will be left there is d, just the d. Then 2 cubed is 64, so we have 64a. 2 squared is 2 cubed is 8, so 8a. Then 2 squared is 4b, then plus our 2c, then plus the constant d. Now we substitute for 4 cubed is 64, so 64a. 4 squared is 16, so 16b plus 4c, then plus d. We substitute the 6. 6 cubed will be 216, so 216a. 6 squared 36, so 36b plus 6c, then plus d. We substitute 8. 8 cubed is 512, so 512a plus 8 squared 64, so 64b plus 8c, then plus d. We substitute the 10. 10 cubed is 1000, so 1000a. 10 squared 100b, then plus 10c, then plus d. Having gotten those values, we find a difference. We subtract this from this, this from this, this from that, this from this, and this from that. So we'll find our first difference. This is only d. We subtract it from this. We'll get a d out there. So we'll get 8a plus 4b, then plus 2c. Now we subtract 8a minus 64. 8a minus 64a will give us 56. So we got 56a. Then 16b minus 4b, that will give us 12. So 12b, then plus 2c. I hope you get that. Let me write it well. So plus 12b, then plus 2c. Now find the difference between this and this. 216a minus 64a will give us 152a, then plus 36b minus 16b. That will give us 20b, then cc minus 4c will be 2c. Then we subtract this also from this. 512a minus 216a will give us 296a, then 64b minus 36b will be 28b, then 8c minus cc, that will be 2c. The last one, 1000a minus 512a will give us 488a. The 100b minus 64b will give us 36b. Then 10c minus 4c, that will give us 2c. Now we find the second difference. So in finding the second difference, we subtract 8a from 56a. We'll get 48. So that will be 48a. Then 12b minus 4b, that will be 8b. 2c minus 2c is 0. Then 152a minus 56a will give us 96a. Then 20b minus 12b will give us 8b. 2c minus 2c again is 0. We subtract this one. 296 minus 512 will give us 144a. Then 28b minus 20b will be 8b. 2c minus 2c again is 0. Then 488a minus 296b will give us 192a. Then 36b minus 28b will give us 8b. Then 2c minus 2c will be 0. We go further to find the third difference. So we'll find the third difference. 96a minus 48a will give us 48a. AB minus AB will be 0. This minus this will also be 48a. AB minus AB is 0. This minus this is also 48a. AB minus AB is also 0. Having gotten those values, we equate. That means that 48 equal to 48a in that order. 24 is equal to 48a plus 8b. I hope you get that. Or 72 is equal to 58a plus 12b plus 2c. Anyone you equate. And this is also equal to this. So first, look at this. 7 is equal to d. So d is 7. We don't have problem with that. Then 48 is also equal to 48a. So we can say our d is equal to 7. Then 48a is equal to 48. We divide both sides by 48. A is equal to 1. So our a is 1, d is 7. So we can also say that 48a plus 8b is equal to 24. So 48a plus 8b is equal to 24. What's our a? Our a is 1. So we substitute the 1 plus 8b is equal to 24. 48 times 1 is still 48. Plus 8b is equal to 24. 8b is 24 minus 48. 8b will be negative 24. We divide both sides by 8. b will be equal to negative 3. So we know our b now to be equal to negative 3. We find our c. Remember 8a plus 4b plus 2c will be equal to 6. So now we substitute the values of a and b and c into this to get our a and b to get our c. So 8, our a is 1, b is negative 3, plus 2c is equal to 6. 8 times 1 is 8. 4 times negative 3 is minus 12, plus 2c is equal to 6. 8 minus 12, that's negative 4, plus 2c equal to 6. 2c will be equal to 6 plus 4. 2c is equal to 10. On divide both sides by 2, our c is 5. So c is equal to 5. So we know our a to be 1, b to be negative 3, c is 5, d is 7. We substitute here to get our polynomial function or to get the rule for the mapping. So we can say the rule for this mapping is that y is equal to 1 times x cubed will still be x cubed. So we have x cubed and plus b. b is negative 3. So negative 3x squared. Then plus c. c is 5, so plus 5x. Then d is 7, so plus 7. This becomes the rule for the mapping there. So we have found the rule for this difficult mapping using just difference table. This is very interesting. We'll end it here today. Please remember to subscribe to my YouTube channel before you sign out. Until we meet again, my name is Kepsi.